Okay, so we're going to look at some problems for section 5.4, specifically the kind where you add up. So let's, so this is the one from the video, so we'll just continue on with that, but it ties into some of the homework problems. So the idea is if you know part of it, you know this and this, and this, then we can combine those to find other integrals. So what we need to remember is there are a couple of things that we remember about integrals. Multiplication by constant and addition and subtraction carry through. So if you've got this, you know, f plus g, two different functions, you can split those apart. You can split those apart, or it means you can put them back together. So that if you know this piece and this piece, you can add them together to get the whole thing. So that's one way of combining integrals. And then the other way is, if you know that you're going over a whole range, you can add up part and then add up another part and kind of butt them together. So if you have this going from A to C, and you know you've got a break point in the middle of B, you can go from A to B, because you're adding up, and then keep adding from B to C, and you'll end up having the whole A to C. So there are two main ways that we combine integrals. One is just having addition and subtraction carry through, and one is butting intervals together to make a bigger one. Okay, so let's look at this one. So if I wanted to know the integral from 0 to 2 of 7x dx, well, I know that multiplication, this is a constant. Is this a basic? That's always our first question. Is this a basic? Yes. There's nothing fancy about that. There are no composite functions, nothing strange. So this is just multiplied by 7. So I can pull that 7 out front. We've been doing that when we have been doing the inverse chain rule substitution type problems. Do I know this piece? Yeah, I know this piece. That's 2. So I can just say 7 times 2 is 14. And if you wanted to, if you see that step and don't need to write that step, I'd like to see something, so 7 times 2 would be enough work for me. But then let's say, let's say you have this, 0 to 2 of 7x plus 3x squared. Okay, I know x, the integral of x, and I know the integral of x squared. So here I have multiplication by constants, that carries through. Let's make this a minus. And a subtraction, that carries through. So that means that I can combine the answers that I know. So I know I'm going to have 7 times the 2. That's going to be the integral of this piece. Minus 3 times the integral of that piece. So minus 3 times 8/3. 3's cancel. 14 minus 8, 6. So I can combine them that way. Because, and this is true in general, whenever you're doing integrals, or for that matter, derivatives, you can do them piece by piece. Is that a song? No? Step by step? Oh, there's a song that sounds familiar. Anyway, okay. All right, so the last thing that we're going to look at is what if you wanted to go from 0 to 3 of 3x squared? None of these are 0 to 3. But I have 0 to 2, and then I can continue on 2 to 3. So if I combine these two all together, because you can think of, this is sort of like a kind of a long, skinny S, and you can think of that S for sum. That's really what you're doing. You're adding up. So if you start adding at 0 and add all the way through 2, and then keep going and add all the way through 3, it's the same as if you just added from 0 to 3 in the first place. So that means that I can treat this way. I can say, well, I know from 0 to 2, and I know from 2 to 3. So altogether, I would go from 0 to 2 on to 3. So you can split it apart that way. Okay, so 0 to 2 of 3x squared. I know 0 to 2 of x squared. So 0 to 2 of 3x squared is just going to be 3 times that. So 3 times 8/3. And then from 2 to 3, same thing. The integral from 2 to 3 of 3x squared is just going to be 3 times this one. So plus 3 is 19/3. All the thirds and threes cancel. 8 plus 19, 27. So that the important part of section 5.4, because we're going to move on to section 5.5, which is going to take some of this, but then add the bit about antiderivatives and put it all together. The important piece here is, just like with derivatives, multiplication, subtraction, addition always just carry through. You just treat each piece one at a time and just multiply by whatever you got out front. The second piece we've added is this idea of breaking up the interval and adding some, and then adding some more, and that being the total sum. Is that better? Okay. Very good. All right, that's a good recap. Why don't we stop